In the last videos, we have learned what a node is, how to communicate with them through topics and services, and we have coded them in Python and C++. In this video, we are going to put it all together dealing with a project using Turtlesim simulation. The scope of this project is to make the turtle do a pathway of a S shape, like what a cleaning robot will do. To do that, we will create two nodes. The first node subscribes to the topic Turtle1 pose to display on the terminal the position of the turtle in X and Y, while in the second node we will describe to the topic Turtle1 pose and will publish a message of type geometry message twist on the topic Turtlesim command val that set the linear and angular velocity of the turtle according to the position of the turtle in the environment. Then we will use a service that teleports the turtle at a certain position for starting the new pathway along the environment. Before diving in, I remind you to subscribe to the channel if you get values of this type of videos and you want to master your competence on programming robots with ROS. And now let's get started. The first things that you need to do is to create a new package of this project. And this project we're gonna call it Roomba Pathway and add the dependencies. ROS CPP, ROS Pi, Turtlesim, geometry messages, standard services and standard messages. Then build the package by typing cat-make and open Visual Studio Code. Let's create the first subscriber node and call it Roomba _pose check. The first thing that you want to do is to include the header file ROS, standard message, geometry messages twist and pose2d, the Turtlesim pose and finally IOStream that allows us to interact with the command line. We're going to follow the same structure as we did in the previous videos when we created the subscriber. Let's create the main section and initialize the node giving it a name. For example, Roomba _pose. Now create the node handle object as always. Let's create the subscriber object that is going to subscribe to the topic turtle1/pose. And we are going to handle the data received in the callback function. Let's finish this section with the spin function that I remember you that allows you to do and do it again like it is a while loop, the main section, and finally, before to finish the main section, return 0. Finally, before we code the callback function, we can create a Turtlesim pose object that we are going to use as input in the callback function. Now we are going to create the callback function. We can use an object of type geometry message pose2D and use the pointers to give in the position in X and Y. Then we can display on the terminal the value of the pose where the turtle is. And there we go, the script is already finished. As you can see, it's a very simple one. Now let's build the file, creating an executable file, adding the 2 lines in the cmakelist.txt file. Let's check the package.xml file to see if all dependencies needed to run the package properly are in this file. They are in there, as you can see, because we have already added when we have created the package. And now everything should be ready, and let's build the package by typing cat make. Then run the Roastmaster by typing wascore and start the simulation with the Turtlesim environment, and to do that you just need to run the Turtlesim node and here we go, we can see our turtle is at the center of the environment. And finally, to see if everything works well, you can run the subscriber node created, and you can see that the pose is displayed on the terminal. And in this case, the turtle is in position roundabout 5 in X and 5 in Y. To check the functionality itself, meaning that while the turtle is moving around the environment, the position in X and Y are changing accordingly, we can use the teleop key nodes using the arrows of your PC keyboards. And as you can see, when the turtle is moving in the environment, the pose X and Y are updated accordingly. Fine, that was very easy and nothing new of what we have learned in the previous video, where we have dealt with the subscriber. Now let's raise the bar a little bit and create the node that controls the turtle by making a S shape when the turtle is approaching the edge of the environment. We are going to create this node dealing with it a class, which is very useful when the nodes are getting more and more complicated. The class gives you a good structure for dealing with objects. First, let's create the main section that this time is very simple. You can initialize the node, giving it the name pathway, and create the object Roomba control that will do all the job. Then spin like an infinite while loop and return 0. And here we go, you have already finished the main section. And now we're gonna create the class Roomba Control. This structure is very useful if you want to avoid generating global and local value in the different function of the script. In the private section, we are going to put objects and variables accessible only inside the class itself. So here we create the node handle object, the publisher, the subscriber, the variable of type geometry message post2d, useful for identifying the x and y position of the turtle in the environment, and the geometry message twist, which is the type of the topic command val. Now we can build our constructor where we create the publisher that will publish a message of type twist on the topic command val. And then we create the subscriber that subscribes to the topic turtle1 pose, and we're gonna handle this data in the callback function. Since the callback function belongs to the method of the class Roomba controller, we need to type this. Then we can write our callback function that is accessible everywhere in the class. In this callback function, we are gonna use a message of type Turtlesim pose as input. Then we are gonna use pointers to associate the variable of type pose2d created in the private section. Then we are gonna do something with the position of the turtle. And for example, if the position is overpassing the value of 10 in x, then we modify the object command of type geometry message twist to turn left, moving by 180 degrees. And for doing that, we can set a linear velocity to 0.8 and angular velocity in z of 1.2. These are values that I have already tried before. Well, generally speaking, the more value you give in angular velocity respect the linear velocity, you're gonna make the turtle turn with a short curvature radius. And feel free to try different values and see how the turtle behaves. Then, if the position of the turtle in x is lower than 1, we let the turtle turn right. And the condition in else, we make the turtle go straight, and we just need to set the angular velocity z in 0. Finally, we can publish the object command on topic turtle1 command. Okay, the script should work like this. This is a new way to use a node that contains both publisher and subscriber, and we use the class structure, so we avoid to use any global and local values. Then we need to update the cmake_list.txt file asking to make the script executable. So type cat make for building the package, and start the roastmaster first. Then run the Turtlesim node, that is gonna be the simulation environment, I remember you. And then finally, you can run the Roomba pose check node, which subscribe to the topic Turtle1 pose. And then we can run the Roomba controller. Okay, as you can see, it's working properly. You can see that the turtle, when it's overpassing 10 in X, it turns left, and when it is lower than 1 in X, it turns right. As you can see, when you are at the edge of the environment, the turtle is stuck on the top. So we will need to move the turtle in another place. And for doing that, we can call the service Turtle1 teleport absolute. And let's see what's happened before to put it into the script. So we need to put three values, x, y, and the orientation in theta. And here we go, the turtle is starting over from the position 1, 1, as we set before. And furthermore, we can clear the pathway history. And if you want to call this service via script, we need first to check the type of the message Turtle1 teleport absolute. And for checking that, we can see that it is of type Turtlesim turtle absolute, and we need to pass the arguments x, y, and theta. Okay, let's raise the bar a little bit and add this service in the script. So first let's include the teleport absolute and the empty header file, as we checked before. we add two service client objects, one for teleport the pause and one for clear. Then we go to the class constructor and we define the service client that will raise a request to the service Turtle1 teleport absolute. Then we're gonna define the service client that will raise a request to the service clear. Now we can set the request variable and we can set the condition for raising the service request. And it's gonna be the request.x, request.y, and request.theta. Then we can say that if the pause in y is greater than 10, we are gonna call the service for teleporting the turtle and the service for clearing the pathway. Okay, everything is should set up. We can build the package and run the simulation again and see what's happened. Okay, it's working. The services are called from the client properly. That's all for today. I hope that you enjoyed this video. If you got value, subscribe to the channel and don't hesitate to reach me out if you need ROS support, and comment down below your thoughts about these type of tutorials. We're gonna use again this package for practicing with the custom messages and services which we are going to deal with in the upcoming videos. Thank you for your attention and keep learning robotics with Ross.